Good evening. Welcome to Cornerstone Home Inspector Education Center. Tonight, Stan Bajerski will be presenting combustion air and venting safety for home inspectors. If you have any questions during the webinar, please feel free to type them in the chat bot, or if it's more involved, you'll just see what a natural break is and you can just unmute yourself, ask your question. That is okay. And then we just do ask that when you are not speaking, just have your microphone muted at all times, and I'll hand it over to Stan.
Hey guys, thanks for attending tonight. Tonight, as Jim said, we're going to talk about combustion air and venting safety for home inspectors. This is a topic I think that I know I find issues many times a year. And I think sometimes they're so small that other people may overlook them or not really report on them. So we're going to kind of get into all that and some of the causes and recommendations if you find these things. So we're just going to talk about the state of Connecticut standards, but it generally is the same as all the other states that we kind of cover. It doesn't specifically detail what to look for in the vent system, but it does mention, for instance, it says the inspector and the heating system shall inspect the installed heating equipment and the vent systems. That's about it. As far as mentioning the vent system, the flues and chimneys, the inspector shall describe the energy source and the heating method by its distinguishing characteristics. The inspector is not required to inspect the interiors of flues or chimneys which are not readily accessible, the heat exchanger, humidifier, dehumidifier, electronic air filter, or solar space heating system. The inspector is not required to determine heat supply adequacy or distribution balance. So that's I believe, the only section of the standards where the vent system is even mentioned. And of course, it doesn't really tell you what to look for, even though the standards are meant to try and get us all on the same page. So today we'll kind of corral that a little bit for those of you that may be new and need a little bit more information on it, and just a review for those of us that have been doing this for a while. So why this matters, the stakes are kind of high because it is a safety issue if we're not venting properly. So improper combustion air and venting aren't just code violations, they're potential killers. Carbon monoxide poisoning claims hundreds of lives annually in the United States, many of which could be prevented through proper inspection and identification of combustion system deficiencies. As home inspectors, you serve as the first line of defense in identifying these hidden hazards before they harm your clients and their families. Now, if you've been inspecting long enough, you know that heating systems are not always maintained properly. And that is where one of the issues develop, right? We're not maintaining them properly. Some of these things start to develop. They're not caught right away and they turn into big problems. So you got to have that eyes open when we're doing the venting. Okay, Jim. Today we'll talk about combustion air supply, or tonight I should say, venting configurations, safety hazards, clear reporting. So we want to understand how combustion air is properly supplied to fuel burning appliances and recognize when it's inadequate. We want to recognize common venting problem systems and their problems, their proper installation requirements and typical defects. Identify dangerous conditions caused by improper air supply, venting failures, and backdrafting, and clearly communicate combustion air and venting deficiencies effectively in your report to protect your clients and yourself. Understanding combustion, the foundation. Before we can identify any of the problems that may be associated with combustion and venting, we need to understand what's supposed to happen. Combustion is a chemical reaction that produces heat. It's what makes furnaces warm homes and water heaters provide hot water, obviously. But this reaction requires specific conditions to occur safely and efficiently. First, we need a fuel, natural gas, propane, or oil that provides the energy source for heating. We need fresh air supply necessary for combustion reaction to occur, and an ignition source So a pilot light, electronic igniter, or spark that starts the combustion process. Remove any one of these three elements and combustion cannot occur, but having all three doesn't guarantee safe combustion, and that's where proper air supply and venting become critical. So an easy explanation or example would be you have a candle burning, you cover that candle, you take away the oxygen, the flame is going to go out. Depending on the size of the flame and how fast it goes out, it may give off some soot. Same thing's going to happen in a fuel burning appliance if those mixtures are not right. Go ahead, Jim. If you are viewing this as a pre-recorded webinar, record the number CA7346. There'll be one more in this presentation, and send them both to us to collect your certificate. So complete versus incomplete combustion. Complete combustion, when adequate oxygen is present, fuel burns completely and efficiently. This produces carbon dioxide, CO2, relatively harmless, water vapor, H2O, condenses in cool vents, and heat energy, the desired result of the combustion. Incomplete combustion. When oxygen supply is restricted, combustion is incomplete. This produces carbon monoxide, CO, deadly odorless gas, soot and carbon particles, visible black deposits, and reduced efficiency, which is wasted fuel. In a gas burner, the flame appears blue and steady. This is what you want to see. If you're looking at the burner, the flame appears yellow, orange, or lazy, that's a sign of a problem. With an oil burner, the flame should be crisp and clear. If it's smoky, it needs some combustion air. So with an oil burner, you got to open up the inspection plate if you can, if it's possible. You should see a very crisp, bright flame, minimal smoke. If we're not getting enough combustion in there, it's going to be a very smoky fire. It needs to be adjusted. I will tell you that with oil, you're less likely, unless the heating equipment is really, really in bad shape as well, to provide enough, produce enough carbon monoxide to become a major issue, but it's still an issue. Okay, Jim. So here are a couple pictures of the fuel burning. So the picture on the left is obviously a gas-fired heating system, and that flame is very blue, very crisp. It's not moving. Well, we can't tell that, but it shouldn't be moving. And you'll never see a flame with this side cut out, but with an oil burner, that's kind of what it looks like. And again, it shouldn't be smoky. It should be pretty crisp when burning properly. Okay, Jim. So carbon monoxide is the most dangerous byproduct of incomplete combustion. It's colorless, odorless, and tasteless, impossible to detect without specialized equipment. CO poisoning symptoms mimic the flu, headaches, dizziness, nausea, and confusion. At high concentrations, it causes loss of consciousness and death within minutes. Every home inspector must understand that identifying conditions conducive to incomplete combustion isn't just about code compliance. It's about preventing tragedies. When combustion air is inadequate or venting is compromised, CO production increases dramatically. Jim? Backdrafting, when exhaust comes back inside. Backdrafting occurs when negative air pressure in a building prevents combustion air from properly venting outdoors. Instead, they're pulled back into the living space, bringing deadly carbon monoxide with it. So pressure imbalance created in a house can be the result of exhaust fans, dryers, or other mechanical systems that create negative pressure by removing air from the home faster than it can be replaced. Natural draft overcome. The negative pressure overpowers the natural upward draft of the venting system, reversing the flow of combustion gases. So that could be if you have a whole house fan, it's winter, all the doors, and I don't know how this scenario could happen, but every door and windows are generally closed because it's cold outside, and you have a fireplace on, or your heating system or water heater is operating, if that fan's on high speed, it can overcome the draft in any one of those appliances and pull everything back in the house. So generally you wouldn't be running the whole house fan, but that's big enough to pull the air back down the chimneys if there's nothing else open. So, you know, always a door or window open when you're operating that whole house fan. Spillage into the home, carbon monoxide, water vapor, and other combustion byproducts spill into occupied spaces instead of safely venting outdoors. So common fuel burning appliances. As inspectors, you'll encounter various combustion appliances during inspection. Each requires adequate combustion air and proper venting through specific requirements vary by appliance type and fuel source. So we have the forced air furnace, we have the boiler heating system, we have a variety of water heaters, oil and gas, we have fireplaces. We're not going to talk about fireplaces and wood burning stoves today because they'll be saved for future webinars. We also have cooking appliances that'll burn gas and propane, and dryers. So all these things need combustion air to operate. And quite frankly, all of these can be operating at one time. So it's not impossible to be drawing a lot of combustion air out of a house. Jim? Requirements for combustion air. Combustion air is the oxygen-containing air supply necessary for fuel-burning appliances to operate safely and efficiently. It's distinct from ventilation air or makeup air, though these terms are sometimes confused. Think of it this way. Combustion air feeds the fire while venting removes the exhaust. Both must function properly for safe operation. Combustion air can be supplied from either indoor sources, the space surrounding the appliance, or outdoor sources through dedicated openings or ducts. The method used determines the specific requirements for opening, size, and placement. So generally, when a house is built with an unfinished basement, that whole basement is being used to provide air for the, let's say we have two fuel burning appliances, water heater and a heating system. And then we go and finish that basement off. We actually cut down on the air. The air may still be in there, but we're dividing a basement up into different spaces, and we may not be readily pulling all that air to those heating systems. So we have to be careful when we finish a basement to make sure that we give enough space around the appliances to get enough combustion air. The National Fuel Gas Code, primary standard for gas-fired appliances, addressing combustion air calculation, opening requirements, and acceptable supply methods. Most jurisdictions adopt this with local amendments. International Residential Code. Chapter 17 covers appliance installation and venting. Chapter 7 addresses combustion air for boilers and water heaters, widely adopted in residential construction, and the International Mechanical Code, similar to IRC, but applies to commercial and some multifamily residential buildings, contains more detailed engineering provisions. Now, some guys will, if they suspect a problem, will research these things and try. I know we're on a bunch of Facebook home inspection groups, and I know a lot of guys like to have a specific code reference to back up what they're calling out. I really don't think that's absolutely necessary, but it's not a bad thing. But if you had to go and back up every single thing you're calling out, you're putting a lot of work on your shoulders when there's other ways to do that. So these are the resources if you want to go that route. You're not required to cite specific code sections and reports, but understanding these standards helps you recognize non-compliant installations and explains why they're problematic. So if you're comfortable with your explanation, you don't need to go to those specific codes. So the 50-1000 rule, indoor air method. When combustion air is supplied from inside the building, the most common requirement is providing 50 cubic feet of space for every 1,000 BTU of total appliance input rate. So this chart says you have an 80K furnace, a 40K water heater for a total input of 120K. 120 BTU plus 1,000 equals 120 times 50 equals 6,000 cubic feet required. Again, you're not going to go do those calculations, but generally a mechanical room measuring 10 foot by 12 foot by 8 provides 950 cubic feet. So let's say 1,000, far too small for this equipment without additional openings. This is why you'll often see louvered doors or dedicated combustion air openings in mechanical rooms. So I just had last December that very situation. So I get referred a lot by a couple, a real estate couple, and the husband also flips houses and builds houses. He doesn't swing the hammer, but he gets everybody down there and gets it done. So we were doing a raised ranch, and we came in through the garage. And you know, when you walk in the raised ranch from the garage, almost immediately to your right would be the stairs going upstairs. There's a hallway to go to the main living space. The first door on my left was a bathroom, and the realtor's like nodding his head to the left, and he goes, "This is going to be a problem." So I know the guy has some knowledge. I wasn't sure what he was talking about until I opened the door. So it was the mechanical room. These are two pictures. Now, had I thought about presenting or adding this in a presentation, I would have tried to get a fuller picture. But as soon as I walked in the room, the boiler, oil-fired boiler, was tucked in the left corner. The room was about, I'm going to say 8 by 12. I didn't measure, obviously. And there, the water heater was indirect, so there was one appliance. My eye first caught the water staining on both sides of the chimney that I could see. And then that up in the left corner, you could see the vent pipe, the smoke pipe, and it was about a 9 to 10 foot run from the boiler, and very little pitch. I mean, you can kind of tell in that picture even. So I understood what he was talking about because it was a confined space. There were no openings, no louvers. You could see that they framed in the window. Now the kicker was the guy that was selling the house worked for an HVAC company. His truck was out in the driveway, and you know, I wanted to think he's got a toddler and a wife, and I wanted to think that he wasn't putting his family in jeopardy. So I told the realtor and the buyer, I said, look, you could take combustion air out of this room if it met the proper requirements. So you may want to tread softly when you question this guy about it. It doesn't hurt to put louvers in to make sure you got enough air coming in here. And I know why he didn't want them, because he had a beautiful downstairs room where he probably entertained, and he didn't want to hear the boiler running. So I know that they sold a house. They came to some kind of agreement. I don't know how they approached it, but they did sell the house because I saw it on Facebook. So something was going on there, whether it was a leaky chimney or not venting properly and the moisture condensing before it was going all the way up the chimney. Whatever the case was, I wrote it up as needing further investigation. And when I was putting this together, I was thinking about calling just to see how to handle that. But to me, all I need to see is a couple of pieces of evidence, and I know what I'm going to recommend. I don't need to decipher what's going on. I'll just tell them what the potential is and that it's a safety issue and it needs to be further evaluated. Okay, Jim. So two opening method, I think, is what we see most of the time. The most practical combustion air solution for confined spaces is providing two permanent openings, one near the ceiling and one near the floor. This creates natural air circulation through convection. The key requirements for this approach would be each opening must be at least 1 square inch per 1,000 BTU of total input, or 100 square inch minimum. Upper opening placed within 12 inches of the ceiling. Lower opening placed within 12 inches of the floor, so we get complete airflow through both of them. And openings must communicate with outdoor or an unconfined space. So you can't put it in another little room because that room may not have enough air either. And common solutions include louvered doors, transfer grills, or ducted openings to outdoors. Common combustion air supply methods. Louvered doors, we see that all the time. You will hear the operating noise through the louvers. So it's pre-manufactured door with fixed louvers providing required free area. Always verify louvered sizing and calculate actual free area to meet code requirements. Transfer grills, same thing, just in different locations. Wall or door mounted grills. Connect to mechanical room to an adjacent conditioned space. They must be correctly sized to provide the necessary free areas. You can duct directly outdoors. You've seen this too, and a lot of times in condominiums. Dedicated ducts bringing outdoor air directly into mechanical room requires proper termination, screens, and weather protection, especially in colder climates. And then mechanical combustion air, fan in a can, whatever you want to call it. Powered fans deliver combustion air interlocked with appliance operation. This method is less common in residential settings and typically requires professional designs. And they are problematic and prone to malfunctions. But if you have it, you have to, they should be maintained as often as the boiler, the heating system is maintained. Another quick story. Last week, I was asked by somebody I haven't seen for 35 years. Scott and I coached his daughter in baseball. My son's 34, so 29 years ago. They're moving, and he wanted me to come and do basic pre-inspection of his house so he knows what to expect. They just had a new high-efficiency gas-fired furnace put in, and it kept on going, locking out. They sent like 3 techs down there, and it kept on locking out. So finally, I guess the big guy came down, and he found a leave in the makeup air pipe from outside. A leave that lodged itself in there because there was no screen and blocked enough of that pipe that they weren't getting enough combustion air. Now, luckily, there's an interlock and shuts it right down. So once he found the leave and cleared it out, they put a screen on the pipe, and they've been fine ever since. So that was a scenario that has a safety on it. That wasn't a big issue except for no heat. So these are the kind of things that, you know, you may have noticed that if you stick around the furnace long enough that it wasn't running. So these are all the kind of things you want to kind of be aware of as you're doing your inspection. Okay, Jim. So field clues, recognizing inadequate combustion air. So you won't always have the time or access to perform detailed combustion air calculations during inspections. Instead, learn to recognize the visual indicators that suggest insufficient air supply. If you see any soot, any place inside the burner compartments, on top of the water heater, coming out of ductwork, the soot deposits around burners, draft hoods, or appliances are visual clues that point to incomplete combustion due to insufficient air supply. Pilot light problems. Frequent pilot outages or unstable pilot flames often indicate a lack of air for stable combustion, leading to repeated service calls. You may not know that unless it occurs during your inspection. The yellow or lazy flame. Flames should be crisp and blue. Yellow, orange, or wavering flames signal a poor air-fuel mixture, indicating restricted combustion air. You know, there's air adjustment on gas burners too. Jim, if you go to that second picture, the green furnace, you see the slots at the front of the burner jets. They can be moved to open up the air to help that burn properly. That would be makeup air versus combustion air or primary air. And then visible backdrafting, smoke or condensation stains, melted vent connectors, or corrosion around the draft hood. These are all strong signs of combustion gases that aren't venting correctly.
Let me ask you a question. On the first one, black soot deposits,
Yeah.
that could be a cracked heat exchanger too, right?
I don't know if it would get out there, but yes, you could get the soot from the heat exchanger.
So it's possible. Could be either.
Yeah. I would say it was probably more from combustion. I mean, I see it most of the time in the compartments or on top of the water heater.
Gotcha. Okay.
And sometimes I see it on gas fireplaces. Very rarely, but sometimes I do. So soot doesn't lie. When you see black carbon deposits accumulating around burners, draft hoods, or vent connectors, you're looking at physical evidence of incomplete combustion. This isn't a minor cosmetic issue. It's a red flag that the appliance is producing elevated carbon monoxide levels. Document sooting conditions with photos and recommend immediate evaluation by a qualified HVAC professional. Use language that conveys urgency without creating panic. Evidence of incomplete combustion observed, further evaluation recommended prior to closing to assess safety and proper function. It's kind of important. And that's why I'm saying some people will see that and just think, oh, it just needs a service. It's not that bad, but there's a reason for it. Okay, Jim. Venting systems, getting combustion gases out of the house.
Oops, sorry. Hold on.
Even with adequate combustion air, appliances are dangerous without proper venting. The venting system serves two critical functions. It removes combustion byproducts, including carbon monoxide, carbon dioxide, and water vapor from the building. Creates draft that helps pull fresh combustion air into the appliance and moves exhaust gases upward and out. Venting failures are arguably more immediately dangerous than combustion air deficiencies because they trap deadly gases inside the building rather than allowing incomplete combustion to occur. So the different types of venting systems, the natural gas draft or type B vent relies on the natural buoyancy of hot gases to vent through single or double-walled metal pipes. Commonly found in older furnaces and water heaters, this system requires proper rise and termination height. Induced draft employs a fan mounted directly on the appliance to actively pull combustion gases through the vent system. This allows for smaller diameter venting and some horizontal runs, typical in mid-efficiency furnaces. The power vent features a fan that pushes combustion gases through PVC or other approved piping, often terminating horizontally through a sidewall, used with higher efficiency appliances, creating positive pressure within the vent. And then direct vent sealed combustion, a completely sealed system that draws combustion air from outdoors through one pipe while exhausting through another. It prevents indoor air use for combustion, offering the safest venting method. Natural draft venting. Natural draft venting is still common in millions of homes. These systems depend on physics. Hot gas rises because they're less dense than the surrounding air. This creates draft that pulls combustion air into the burner and moves exhaust up the vents and outdoors, kind of like attic ventilation, right? The hot air is rising, pulling in the cooler air. Critical requirements for natural draft venting. Vent connectors must slope upward at least a quarter inch per foot. Properly sized for appliance BTU input. Undersizing restricts flow. Minimum rise for draft hoods to terminate varies by code. Proper clearances to combustibles maintained. Secure connections with approved fasteners, and termination above roof surfaces per code. So you could see kind of a drawing there with some of the clearances that are required. There with the gas, there's a little vent hood on there that's open to the atmosphere. And generally with an oil-fired furnace, there's a draft regulator and that pipe goes right onto the water heater or furnace. without that gap. Okay, next.
Stan, can you just talk a little bit about, I know we've seen it a lot and we see it more about, when you orphan, say like you used to have two natural gas appliances, whether it be a boiler, furnace, a water heater, and now they go high efficiency. What are some of the things that we're seeing as a result of that? They pull one out, they put a high efficiency in, and now you have just the water heater that's going up that chimney all alone.
Yeah, we're going to hit that again coming up, but I'll talk about it now since you bring it up. So when we started getting the higher efficiency or the condensing style water heaters, a chimney's supposed to be sized for two appliances. If there's we'll stick with gas. We have a gas furnace and a gas water heater, and somebody needs a water heater and they put in a condensing style water heater. So now we don't have that second appliance going into the chimney. And I've seen this, and people are getting water in their basement, water into the chimney, and they're looking all over the place. They're adjusting their grading, and they can't understand why water is coming in the house because we're too big, or the other way around, actually, too. The furnace is high efficiency, and the water heater is very small appliance in that big chimney. So theoretically, we're oversized, and we're not getting that flue gas out of the chimney, and it's allowing the condensate, the moisture that we're releasing when we're burning the gas to condense, and come back down the chimney. But isn't that so? I used to argue that. Then I thought out a little bit more. So doesn't that water heater run by itself in the summer? And we may not have that problem in the summertime? Or is it able to use that chimney by itself in the summer because the temperatures are different? It's warmer outside. I don't have the answer, but I used to say, well, furnace doesn't run in the summer and the water heater is fine all by itself all the summer that furnace, before they change that furnace out. So
colder.
I made it a practice to call that out all the time, just in case. But, anything we burn, wood, propane, natural gas, oil, a byproduct is H2O. And that we got to get that out of the house. So I see problems in the big old three family houses with the tall chimneys not getting the proper draft all the way up and having some moisture problems in the chimney or liner problems because maybe that condensation doesn't come all the way back to the bottom. It sits in the chimney liner and starts to deteriorate it. But with a ranch, you shouldn't have a problem at all. It's one story and it usually gets out pretty well. So you really got to take in a lot of factors when you're looking at stuff like this. But if you open that inspection plate and you see little particles of the lining down there or chunks of it, there's a problem. Something's going on with the chimney or the drafting, and you got to call somebody. You got to make that call. So common venting defects you'll encounter. Disconnected sections, occasionally, they could separate at the joints due to corrosion, building settlement, or improper installation leading to immediate spillage of combustion gases. Vent diameter too small for the appliances. BTU input creates excessive resistance leading to spillage. That might be a hard one unless it's grossly undersized and you're going, what the heck? Back pitch, that I see fairly often. The vent connectors slope downward instead of upward, trapping condensation and impeding gas flow, leading to corrosion and eventual failure. Excessive horizontal runs, I see that kind of often too. I saw it twice. There's another one coming up, an example that I ran into recently. So long horizontal sections reduce natural draft effectiveness. It makes sense, making the system vulnerable to backdrafting with pressure changes. Corrosion and deterioration. I think we've all seen holes that rusted through, corroded seams, or deteriorated materials that compromise vent integrity, often occurring in unheated spaces due to condensation, and then blocked terminations like the leave. You could have a blocked exit as well, bird's nests, leaves, and other debris blocking the vent outlet at the roof, preventing exhaust from leaving the building properly, so it all backs up. It's like putting a potato in your exhaust, right, of your car, the person that you're pissed off at. When vents fail, it creates problems. So vent connector corrosion is one of the most common defects you'll document. It typically starts where condensation accumulates in horizontal sections and elbows or in cool spaces. Small pinholes grow into gaping rust holes over seasons. Now, what bothers me is that these appliances are being serviced and these things are developing and nobody's calling them out. And I got a big problem with that when I see it. And I'll see these problems and I'll see that the units have been fairly routinely maintained, and I just scratch my head. Don't minimize this defect. Holes in venting means combustion gases, including carbon monoxide, are escaping into the living space. Your report language should reflect the seriousness. Vent connectors show significant corrosion with multiple perforation holes observed. Replacement required to prevent carbon monoxide hazards. Viewing code. If you're looking at this as a pre-recorded webinar, record GH6732, send in both numbers to get your certificate.
Also, just to break in, when you do send in for your certificate, there's buttons everywhere that says submit for your certificate. So you'll click on that, you'll pick the webinar that you watched, you'll put your codes in there, your information, and you just hit submit and a certificate will be sent to you. Do not email us for your certificate. Just go onto the website, fill out the form, and you'll get your certificate.
Shared venting, another situation I see a lot that's done the wrong way. Many homes have a furnace and water heater sharing a common vent. This is called common venting or manifold venting, while code compliant, where when properly designed, it introduces additional complexity and potential failure modes. The common problems with shared vents: undersized common vent for combined BTU input, improper connection angle, should enter at 45 maximum, orphan water heater after high efficiency furnace replacement, incompatible appliance types sharing the same vent. The orphan water heater scenario is particularly problematic when an atmospheric furnace is replaced with a high efficiency unit that vents separately. The water heater is left alone on an oversized vent. This creates weak draft and condensation problems. So we kind of discussed that. I'm sorry, I was talking about the water heater being replaced instead of furnace, but it's definitely the other way around. The water heater is all by itself. So I did a condo right before the end of the year. I again couldn't get a full picture of it, but the water heater was on the left, the furnace was on the right when you were looking at it from the stairway into the basement. And that probably was another 9 to 10 foot run from the water heater to the furnace. All right, that was a T on the top of the water heater. No, I'm sorry, not T, a 90. So that thing took an immediate turn, which is going to restrict some of the flow. And those two rings were melted at the bottom of the water inlet and at the bottom of the outlet. And then it went with, I'm saying minimal pitch. I don't think there was pitch on it. I don't check it, but it looked like it was going straight across into a T. So if this furnace turned on while the water heater was running, it's a bigger appliance. It's going to push momentarily, maybe for a long time, the gas back on top to the top of the water heater. So that whole thing, they claim, existed like that since the condo was built. And I'm saying, okay, it's not right, and somebody's got to check it out. Next. So there's the melted. They're not badly melted, but they're melting, and a lot of soot and buildup, rust inside the burner compartment. So that's all I really needed to see to sell my point. And again, I don't know how far they got with the sale. There was a couple other issues. The buyers were the girl was very picky. We did a condo prior to that, and they did not buy it because it smelled like cigarette smoke. So They didn't call me back for another one, so I'm sure they came to some kind of conclusion there. So proper vent rise and slope. Natural draft venting requires both vertical rise and proper slope to function correctly. Think of it as creating a chimney effect. The taller the vertical rise, the stronger the draft. The upward slope ensures condensation drains back to the appliance rather than pulling in horizontal sections. The vent connector must rise at least a quarter inch for every 12 inches of horizontal run, at least 12 inches of vertical rise before entering common vent or chimney, and extend above roof surface per code requirements for vent size and roof pitch. Use the level or smartphone level app to quickly check slope during inspections. If the connector runs level or downward, obviously you document it as a defect regardless of whether you observe active problems. It's just not right. Power vent and direct vent systems. Higher efficiency appliances often use power venting or direct venting instead of natural draft. These systems are generally safer because they're less vulnerable to backdrafting and don't depend on natural draft physics. Power vent considerations. Check that terminations meets clearance requirements for windows, doors, and proper lines. Verify PVC is properly supported and sloped. Look for condensation staining at joints and confirm proper cap installation. Direct vent considerations. Coaxial design, pipe within a pipe should be intact. Verify combustion air intake isn't blocked. Check for ice formation in cold climates and confirm proper gasket sealing at appliances. Some of those might be a little bit out of what we do, but you can at least try and give them a look and see if you see anything that's a concern. Identifying hazards. Okay, Jim. So recognizing backdrafting in the field. Backdrafting is the condition where combustion gases flow backwards into the building instead of venting outdoors. It's one of the most dangerous conditions you'll encounter because it directly introduces the flue gases, which contain carbon monoxide, into occupied spaces. So soot and smoke stains. Black deposits in or around the draft hood, burner compartment, or vent connector indicate combustion gases are spilling into the room rather than venting properly. Melted plastic, as we saw, draft hoods on nearby components show heat damage, warping, or melted plastic. Indicates chronic spillage of hot combustion gases that should be going up the vent. Condensation patterns, water staining on top of the water heater, rust stains in the vent pipes, or white material, mineral deposits near draft hoods suggest combustion moisture is condensing instead of venting. This often accompanies backdrafting and cold air flow. During heating system season, cold air felt near the draft hood, opposite of expected hot exhaust, suggests reverse flow and potential backdrafting conditions. So smoke test, a simple diagnostic tool. While not required by the standard practices, many inspectors carry smoke pencils and matches to verify draft at atmospheric appliances. This simple test can reveal backdrafting that might not show visible evidence. Allow the appliance to run for several minutes to establish draft. Hold smoke source near draft hood openings. Observe smoke movement. Should be pulled into draft hood and up the vent. If smoke spills into the room, backdrafting is occurring. You can use a match. Note that passing a smoke test at the moment of inspection doesn't guarantee the system never backdrafts. Conditions change with whether other operating equipment and building pressure changes. Or you could just lean on a unit and burn your arm, as when Scott and I were working together when he was in training. We were looking at a chimney and the water heater came on and my arm got burned. We wound up shutting that house down. I think we told the story last week or 2 weeks ago. And the fire department came and there was a young girl with her infant on the second floor. And they said that they were getting nauseous and they would open the window. So we told her to leave and we called somebody and they shut the street down and she couldn't go back to the house until they got that all rectified. So one way or the other, there's a couple things you can do to figure out what's going on. All right, Jim. Understanding the threat of carbon monoxide. I think we all know the threat. It's byproduct of incomplete combustion, primary hazard from combustion air and venting deficiencies. As home inspectors, you need to understand CO characteristics to assess risk and communicate dangers to clients. I know some guys use CO detectors, you know, the handheld, or some that they clip on their tool vests and stuff like that. It cannot be detected by human senses. Requires a CO detector. Many victims don't realize they're being poisoned. Mixes with the air and distributes throughout spaces, rises slightly, but not enough to only place detectors high. 35 parts per million causes headaches and dizziness within 6 to 8 hours. 400 parts per million causes death within 3, and 1,600 kills within minutes. Prevents blood from carrying oxygen, so affects our cumulative. Repeated low-level exposures is dangerous even without acute symptoms. Where CO detectors should be installed. I don't really like to get into all this, but CO detector placement isn't typically within the scope of reporting. You should verify their presence and recommend installation if absence. Most states now require CO alarms in all residential properties with fuel burning appliances or attached garages. It should be outside each sleeping area, in the immediate vicinity of bedrooms, on every level of the home, including basements, near but not directly adjacent to fuel burning appliances, in attached garages where vehicle exhaust is at risk. Avoid placement directly next to fuel burning appliances or in areas with high humidity, which can cause false alarms. Battery powered or plug in with battery backup modes both work. Key is having them installed and functional.
If you are confused about this, because we're not going to go over it in this webinar, we have a webinar about the new smoke and carbon monoxide detector law on our website. And then just check your state standards for your specific state.
Testing tools, what's available, what's required. Tools available to us as inspectors: smoke pencils and matches, the draft direction testing, low-level CO detectors, ambient CO measurement, combustion analyzers, detail fuel gas analysis, manometers, pressure differential measurement, thermal cameras, vent leak visualization. The standards of practice do not require that we do any of that. You are required to perform a visual inspection and report observed conditions, defects, and safety concerns. Specialized testing is optional and exceeds minimal standards. So I always say you need to know what you're doing when you do these additional, even if it's part of your inspection or you're selling it as an additional add-on. If you don't do it every day, day in and day out, you really need to be good at what you're doing and know what you're doing. Professional tip: even without specialized tools, a trained inspector's visual assessment can identify the vast majority of combustion air and venting hazards. Focus on mastering visual indicators rather than relying on instruments. I think that's the way to go. You know, it's a no-brainer if you walk in a house and everybody's passed out. I would just turn around, walk out, open the windows and doors, shut off the heating system. I'm being facetious, but I think we can do enough with what we're talking about here not to go through all that with all those pieces of equipment. Okay, Jim. James?
Yeah, you switched it. Do you see it?
Oh, okay. CO poisoning deaths make headlines every season. Many are preventable through proper inspection and identification of hazardous conditions. Consider these actual scenarios. Family of 4 experienced flu-like symptoms every evening. Home inspector during sale noticed several severely corroded B-vent connector with multiple holes. Subsequent testing revealed CO levels exceeding 200 parts per million in living area. Emergency repairs prevented potential tragedy. After high-efficiency furnace installation, contractor failed to resize common vent for remaining atmospheric water heater. Inspector identified oversized vent and weak draft. HVAC evaluation confirmed chronic backdrafting. Proper vent liner installation corrected the issue. Severe weather storm caused ice damming, blocking roof vent termination. Homeowners found unconscious, rescued by fire department. Post-incident inspection revealed completely blocked vent outlet. CO buildup to lethal levels within hours.
Stan, I can break in and give you a real world something that happened just this last month with me. I got a call from an agent whose daughter wasn't feeling well, and she felt it was the water. So as a favor, I went down, I took water samples. And when I was down there, I said, do you mind if I just walk through the house into the basement? I got to confirm if there's filters, all that for the water. And I started talking to her about how she was feeling, what was going on. And one of the things I noticed in the house was CSST, the corrugated stainless steel tubing, and it was everywhere down in the basement. And it was a big boy house. This house had to be 8,000 square feet. And I said, listen, we're going to send the water to the lab, but I don't have any of my equipment here. I'm doing a visual examination. I think you should get a heating contractor in here, check out the CSST, see if there's any leaking, if there's any movement or anything like that. They can get pinholes. I don't see that it's grounded or bonded. Okay. And I knew she wasn't going to do any of it. So I called the agent. I said the same thing. The agent had the heating company go down there. They found a pinhole leak and sealed it. The water came back safe to drink. She's feeling fine. But it was the gas that was making her sick from time to time. She'd go to work, start feeling better, come home, and she gets sick. So it happens.
It does. So reporting deficiencies, communicating your findings. Be specific. Don't write venting problems observed. Instead, type B vent connector shows multiple corrosion perforations in the horizontal section near furnace, allowing combustion gases to escape into mechanical room. Explain the hazard. Connect the defect to the danger. This condition prevents safe removal of carbon monoxide and other combustion byproducts, creating a potentially lethal indoor air quality hazard. Recommend action. Provide clear next steps. Further evaluate and correction by a licensed HVAC contractor is recommended prior to closing. This is a safety priority. And then know your limits. Don't diagnose specific repairs unless you're qualified. Recommend qualified professionals for detailed evaluation. Determination of appropriate corrective measures should be made by a qualified HVAC professional. We talk about that almost every webinar. Sample narratives. The mechanical room housing gas-fired furnace and water heater appears to lack an adequate supply of combustion air. The room door is solid and unvented. No other openings observed. Louvers or grills were observed were not observed to make up air for combustion. An insufficient air supply can result in incomplete fuel combustion, reduced appliance efficiency, and elevated carbon monoxide levels, posing a potential safety hazard. Restricted airflow can also cause draft or backdrafting issues at vent connectors. A qualified HVAC professional should evaluate the mechanical room to determine if additional combustion air openings or vents are needed to meet manufacturer and code requirements. Proper modifications should be made to ensure safe and adequate air supply for all fuel burning equipment. The combustion air adequacy was assessed based on visual conditions at the time of inspection. No calculation or testing of air volume or combustion efficiency was performed. That not only protects your client, it protects you. You've covered all the bases. You've made your recommendation.
It's a recommendation, but also, and we keep hitting this on every webinar, and I've been adding them to my reports constantly, is the implication. And the two main reasons for that is so that the client understands obviously what the issue can be. A lot of your agents now, your newer agents, are not trained as well as your older agents, and they don't read. And so they'll look at an observation, and then I would get a phone call or a text or an email, listen, I'm writing this up to ask for the fix, for them to fix it. Why is this an issue? And so I've been adding this implication. I've had it in the observation of what can go wrong, but I've separated it out so it's easy to read. So I'm really making all my reports an observation, an implication, a recommendation, and a limitation. It's cut my phone calls down from these newer agents to nothing because it's all right there.
I've experienced similar, not a lot, but the new ones are new.
They're not trained at all.
So distinguishing defects from performance limitations. These are conditions you can document through visual, corroded, damaged, or disconnected venting. back-pitched vent connectors, undersized vent diameter when obvious, missing or inadequate combustion air openings, soot, smoke staining, or other backdrafting evidence, blocked vent terminations, improper materials or clearance, performance issues. These are will often require specialized testing or monitoring. Actual CO levels in combustion gases, draft strength measurements, combustion efficiency percentages, intermittent backdrafting that occurs only under specific conditions, pressure imbalances throughout the building. Report what you observe, recommend further evaluation for suspected performance issues beyond visual indicators. Don't forget, I think we all have stuff like this written up that we use, but if you want to add stuff like this, just review this and copy it. I mean, it's all good stuff. So I put a bunch of pictures at the end here in case we needed to kill some time. So they're just obvious stuff like this melted plastic ring around the water pipe. If you
That's
look,
nice.
this guy's directing all that smoke right at that red ring there, right? This side's fine. I mean, there's other issues here, and that one looks like it was just, this one's corroded on the right. That one was replaced, and maybe that's when that thing got dislodged. Who knows? But you just write it up. Okay, to the next. So here I know why they did that. That's kind of like a condensation trap or whatever you want to call it. But if people aren't looking at that, or if somebody comes and services the heating system and they don't call that out, that's going to rust through at some point and be a big problem. So call it out. More rust, more melted rings. When it comes to combustion air and venting, err on the side of caution. If you observe conditions that concern you, even if you can't definitively provide a hazard exists, document them and recommend further evaluation by a qualified professional. Your professional mantra should be, when in doubt, call it out. You're not expected to be an HVAC engineer or combustion specialist. Your role is to identify conditions that warrant further evaluation by those who are. No one has ever been sued for recommending too much safety evaluation. Many have faced liability for missing or minimizing obvious hazards. Remember, you might be the last professional to examine these systems before a family moves in. Your diligence could save lives. Combustion air requirements, the key takeaways. So combustion air requirements, venting is a life safety system. Visual inspection reveals most hazards. Clear documentation protects everyone. All right, Jim, next.
Okay. So Stan, are you
okay,
done?
my pictures aren't in here. All right.
Oh, okay, sorry.
That's okay.
Well, I grabbed the last one that you had, so that was it. And we're at 8 o'clock anyways, but we got some stuff to go over. Logo for your website. If you want to put this logo on your website, you can go to our website under logo downloads, and it's password protected. The password is Cornerstone, and then all the logos are in there for download. We got a lot of stuff coming up. Tuesday, February 17th, we have load bearing walls and beam identification. Then in March, we have water pressure flow and drainage testing. Then that's March 3rd. Then March 4th, we have our in-person in Cromwell on high efficiency heating systems and water heaters. That's a 2-hour credit. It's free to home inspectors. So just show up 7 to 9 p.m. And then March 17th, we have open and closed cell installation. And we're booked through the end of May for courses. And you can go on to our website under calendar of events and see everything there. We also have a monthly newsletter that we've been putting out the last 9 months, the current issues up there on the website. So you can download that. That newsletter is very informative about local, national news in the home inspection industry. We have a narrative of the month. We also have a story of the month. And starting next week, we're going to have a page on our website where you can participate. If you come across something crazy that you want to show us, put in the newsletter or on the website on that page, send us a couple of pictures and a brief description of what happened, and we'll get it up on the website. So that'll be starting next week. Let's see. that's about it. If anybody has any other questions or anything.
I just like to just say welcome to all the new members that are joined us tonight. I know not everybody's up here, and welcome back to all our members. We really appreciate your membership, and we're really going to try over the next year or so. We're going to get some in-person ones, some really good. As you guys know me, we're going to get some really good in-person seminars with a lot of good instructors. So if you also
sorry, Scott, we are going to have more, Stan and I and Scott have been handling these webinars, but we are going to have our occasional speaker from the manufacturer come in, like we had James Hardy and a bunch of speakers. We have a bunch of stuff planned for the second half of the year to get a couple of those guys in.
And to add to that too, Jim, if any member has somebody they know, a buddy that, or you guys have a presentation you want me to, I did that previously with Kahi. If you guys want me to, if you have something specific that you want to talk about, we'll try to get it approved. Most of the time we don't have an issue, we'll get it approved. And, we appreciate you guys, and we would definitely want to make this, and to me, everybody's popping their faces up. We're also going to do, we may have a meeting, whether it's in person or on here. We can just do like a round table that has been brought up in the past, where we can just talk and share experiences, and it may not be something we'll get credit for, but certainly it's something we can do.
Yep,
but
absolutely.
Thank you very much, and thanks for all your hard work, Jim, behind the scenes, and thanks
everybody.
Yeah, thank you all. Appreciate it.
See you guys next month. Tell your